Next on indices, we'll look at exponential equations. Now on the screen we have two expressions, or rather two equations. On the left side, we have 2x equal to 8. 2x equal to 8. If you are asked to solve this equation, this is a simple linear equation. 2x equals to 8 simply means 2 times x is 8. And then, of course, to obtain our x here, we'll simply say divide both sides by 2. So we'll say 2x here, we'll divide here by 2. And we'll say 8 here, we divide here by 2. And then we'll have x is equal to 4. But on the right hand side, the expression 2 raised to power x is equal to 8. It's different from 2x equal to 8. An expression like this is known as an exponential equation. Here we can see that x is not just multiplying 2, rather it's an index or the exponent of 2. The expression here says that 2 raised to the power of x is equal to 8. If we are asked to solve for x in this case, we are simply trying to say what will be the value of x so that 2 raised to power that value will give us 8. And to solve an exponential equation, it will be so nice, or rather, if we can express both the left hand side and the right hand side in the same base. Since I have the left hand side as 2 raised to power x, which is the smaller number in this case, I'll be looking at 8. Is it possible to express 8 as 2 raised to power something, so that the base will also be 2? What then will be the index? Well, we all know, if you look at 8 closely, that 8 is 2 times 2 times 2, which means this will be 2 raised to the power of 3. And of course, since left hand side is equal to right hand side, and the two bases are equal, 2 here, 2 on the left hand side, 2 on the right hand side, then it will make common sense for us to simply say that x is what is 3. Now this is the simplest thing we need to do when we are confronted with any exponential equation. We try to express the left hand side and the right hand side using a common base. Let's take some more examples. Here we have 4 questions. We have to solve the following equation. The first one says 4 raised to power n is equal to 32. The second one is 49 raised to power x is equal to 1 over 7. And we have a third one, number 3, which says 8 raised to power x plus 5 is equal to 1 all over 32 raised to the power of x. And number 4, which appears to be a little bit cumbersome. So let's take them one after the other. Let's look at the first. 4 raised to power n equals to 32. How do I solve this? Now looking at 4 raised to power n equals to 32, we might be tempted to say, okay, since this is 4 and this is 32, 4 is smaller than 32, and we want to quickly do what? Express this as 4, since we have 4 raised to power n, 4 raised to power something. But you know that 4 raised to power 2 is 16. If we try 4 raised to power 3, obviously that will be wrong, because 4 raised to power 3 will be 64. Then at this junction, we'll begin to wonder, what do we then use? 4 raised to power 2 is 16. 4 raised to power 3 is 64. Then we need something in between. Now, since 4 cannot be used, then we look at, can we get a smaller base? Yes. I can express 4 as 2 raised to power 2. So instead of taking it that way, I'll start all over again. So, okay, 4 raised to power n is equal to 32. Since 4 is not suitable, let me try the next smaller number, which is 2. And 2 raised to power 2 will be 4. Of course, this will be everything raised to the power of n. And I say, okay, what about 32? Can I express 32 as 2? Yes, I can express this as 2 raised to power 5. This is more comfortable. Now the left hand side here, we have multiple indices, and you know what to do. That means 2 times n. So the left hand side will now be 2 raised to the power of 2n, while the right hand side will be 2 raised to the power 5. Now left hand side is equal to right hand side, and the two bases 2 2 on both sides are the same. It therefore means that their exponents must be the same. That is 2n here, and this 5 must be equal. So I can say, okay, that implies I can run from here up there that 2n is equal to 5. That the exponent on the left hand side and the exponent on the right hand side must be equal. And that simply takes us to the fact that n will therefore be what? 5 divided by 2. I would have solved for that. I move to the next question. Okay, that's the breakdown again. 4 raised to the power n is equal to 32. What did we do first? 4 cannot play the game, so we decided to make use of 2. Here 2 raised to the power 2 represents our 4. 2 raised to the power 5 represents our 32. Multiply 2 by n, we have 2n, and here we have 2 raised to the power 5. Now both sides are equal, therefore their exponents must also be equal, and 2n is equals to what? Is equals to 5, and we solve that our n is what? Is 5. I'm sure that is not too difficult to understand. Let's advance. Here we have 4 raised to power 9 is equal to 1 over 7. 4 raised to power 9 is equal to 1 over 7. If I look at this, oh, 49 raised to power x, sorry about that, is equal to 1 over 7. So, okay, I look at the left hand side, 49, I look at the right hand side, 7. Yes, 49 can be expressed as 7 raised to power 2. I say, okay, I think I'm comfortable with that. 7 raised to power 2, and I have everything raised to the power of x. And 1 over 7, I think it's better I put it this way, as a negative index, 7 raised to power minus 1. Now things appear nicer. Now this will be 7 raised to power what? We multiply 2 by x, that gives us 2x. And this is equal to 7 raised to power minus 1. Well, since left hand side is equal to right hand side, you will agree, of course, that the left side exponent must be equal to the right side exponent. So I can say that my 2x is equal to minus 1, which means that x is what? Is minus 1 divided by 2. You're still on exponential equation. So you can see that there. First step, what did we do? Change the 49 and express it as 7 raised to power 2, because we have 7 as a smaller number there, and that's the best number we can use to express both sides. And then we have everything raised to the power of x. Then this side is 7 raised to power minus 1. Of course, 2 times x, and we have 7 raised to power 2x. Here we have 7 raised to power minus 1. And of course, we know that the left hand side is equal to the right hand side. Of course, so what do we do? Both sides are already 7, 7. Therefore, their exponents, 2x and minus 1, must be the same. So that takes us down to this step where we have 2x equal to minus 1. And from here, we can conclude that our x is minus 1 all over 2. Sure, we can advance. Here we have solved the following equation. Solve this equation: 8 raised to power x plus 5. 8 raised to power x plus 5 equals to 1 all over 32 raised to power x. Let's take this step by step. I have here 8 raised to power x plus 5 equal to 1 divided by 32 raised to power x. First, let's pay our attention to the 8 and the 32. Of course, we can see we cannot express these two numbers as 8 raised to power whatever. 32 cannot be expressed as 8 raised to power 2 or 3. Now 8 never has to be reduced. If I try to use 4, 4 also will not work. Then I look at the next one, which is 2. So we just keep going down from 8 to 4 to 2. The best number we can use to express 8 and 32 will be 2. So I say, okay, my 8 I know is 2 raised to power 3. Then everything raised to the power of x plus 5 equal to 1 all over 32. 32 is going to be what? 2 raised to the power of 5. Then everything here raised to the power of x. Let's continue. Now I have 2 raised to the power 3. Everything raised to the power what? X plus 5. Remembering what are multiple indices, we can say this is 2 raised to the power 3 times x plus 5. Of course, that is the same thing. The same thing can be done to the right hand side. This will be 2 raised to the power 5 times x, 5x. And I move further here. This is 2 raised to the power 3x plus 15, opening the bracket up there. And then, of course, I can express this as a negative index 2 raised to the power of minus 5x. Now I can do what? I look at my left hand side, my right hand side. Both have been expressed as numbers in the same base. And of course, left hand side equals right hand side. I can then say, oh, my 3x plus 15 is equal to what? Minus 5x. That is, the exponent on the left and the exponent on the right can now be equated. Collect your like terms and solve the simple linear equation. What do? I say, oh, 3x, transfer 5x this other way, we have it as plus 5x. And transfer 15 the other way, we have it as minus 15. And you will agree with me. Let's find somewhere there to finish this up. 3x plus 5x will give me 8x. And this is minus 15. That's obviously is very correct. 3x, 5x, okay. So our x is therefore minus 15 divided by 8. Let's go over this again. Let's go over this again. Okay. Funny enough, this was wrongly solved there. This should have been 2 raised to the power minus 5x. Please, let's correct this. So what we have in the our solution is better than this. There's a mistake here. This is 2 raised to the power minus 5x. So when you transfer your 5x this way, this should have been plus 5x. Remember, starting from here, 8 is what? 2 raised to the power 3. Everything raised to the power x plus 5. And that takes us to 3x plus 15. Here we have 2 raised to the power 5. Taking it up, it gives us 2 raised to the power minus 5, then all raised to the power x. So that should give us 2 raised to the power minus 5x here. So please, there is a mistake here. Remember what we solved just now. Let's go back. Look at what we got here. This is 2 raised to the power minus 5x. So therefore, this is minus 5x, not 5x. So we transferred and it became plus 5x. So what we have on the slide there is it's slightly not correct. So this should be 8. This 8x equals to minus 15. So this should be divided by 8. So the correct answer should be minus 8 all over 15. Sorry, minus 15 all over 8. That's it. Sorry about that. It's a little bit of typographical error. Now look at the last question. Looking at this, we know the best thing to apply is 2. We're going to change our 8 there. We are told here that 2 raised to the power what? 2 raised to the power 3a minus 1 divided by 8 raised to the power a plus 1 is equal to 2 raised to the power a plus 7 divided by what? 4 raised to the power 2 minus a. What do we do here? First and foremost, let us undo the 8 and the 4. And doing that, we can rewrite this as 2 raised to the power 3a minus 1 divided by 8 is 2 raised to the power 3. Then remember we have a plus 1 there already, so keep it there. Equal to 2 raised to the power a plus 7 all divided by 2 raised to the power 3, 2 raised to the power 2 minus a. Let's erase this, please. Let's erase this. We take that again. Now the right hand side, the denominator, look at what we have here. We have here as 4. So 4 will be 2 raised to power 2. And remember, we already have everything raised to power 2 minus a before. So this will now become 2 raised to power 3a minus 1 divided by, and this will be 2 raised to power, now 3 times a plus 1, there will be 3a plus 3. Talking about this expression here, if you open that bracket, and y here we'll have 2 raised to power a plus 7, and the denominator right hand side will therefore be, opening this bracket here, will give us 2 raised to power 4 minus a, sorry, minus 2a. So that's it there. That's where we have arrived. Here we have 2 raised to power 4 minus 2a, and here we have 2 raised to power 3a plus 3. Now what do we do next? I can apply one of the laws of indices. Remember, we said somewhere that a raised to power m divided by a raised to power n is equals to what? A raised to power m minus n. You can apply that to the left hand side and the right hand side. Here we have 2 raised to power 3a, and here we have 2 raised to power 3a plus 3. They are dividing, so I can simply say this can be expressed as a single expression as what? 2 raised to power 3a minus 1. That sounds like my m. And then minus, I'm subtracting the exponent of the denominator, but let me put it in bracket because there are 2 terms there. 3a plus 3. So this is like my m minus n. And I do the same thing to the right hand side. I say this is 2 raised to the power of a plus 7 minus, now my n will be 4 minus 2a. I'm putting that in bracket because there are 2 terms. So I have to be careful when I'm opening that bracket. Now, simplifying this, we have here 2 raised to power 3a minus 1. Then opening this bracket, I have minus 3a. I'm talking about here. And then this will be minus 3 equal to 2 raised to power a plus 7. Open the bracket here, I have minus 4. And then minus will give us a plus, then 2a. Of course, simplifying further, 3a minus 3a is gone. Minus 1 minus 3 will be minus 4. So I have this as 2 raised to power minus 4. And I come to this side, a plus 2a will give me 3a. I say this is 2 raised to the power of 3a. And then plus 4 minus 7 will give us plus 3. Now we have arrived at the simplest of all states in this equation. The left hand side, of course, still is still equal to the right hand side. And we can say that our minus 4, which is the exponent of the left, is equal to the exponent on the right, 3a plus 4. So I can bring this down as minus 4 equal to 3a plus 3. Well, let's move to the next slide because we don't have space anymore here. And let's see. Yes, that is where we are. That's where we are there. Let's take it all over again. Look at what we did here. At this point, we applied the rule a raised to power m all over a raised to power n equals to a raised to power m minus n. So this is our m for this side, and this is like our n. So we subtract n from m, and we do the same thing for the right hand side, a plus 7 minus 4 minus 2a. And then opening the brackets, we arrive at this. Opening the brackets here, we arrive at this, and then simplifying that. Of course, we can solve for our a here by dividing both sides by 3, and we have a equals to minus 7 divided by 3. That's it. Next video clip, we'll continue on exponential equation. This was a bit lengthy.